Hey guys, you guys hear me?
Yep.
Hey
Can
guys,
hear.
welcome to
Hello.
our. Arisa, how are you doing?
Doing pretty well. I mean, I guess the next, like last week we kind of mentioned something about the Singapore election coming up. I guess now it's all over. Then I guess everything's all good and all. It's a pretty eventful one. I mean, kind of interesting to see the trends, and then the more interesting thing is to see the commentary around all the stuff that has been happening throughout the whole, how many days was it? The whole political event, 7 days ish.
Yeah, around 10, I think. 7 to 10
10.
days. Yeah, they had some time to campaign and there was a cooling off day and everything. But it was quite exciting. Like, the ever first time we had like all these elections, the festivities in a way, everything was online. No one, you can't campaign. In real life, the most you can give is flyers and stuff. But it was exciting to see like everything done online. There were TV broadcasts. They streamed it to YouTube as well. In fact, I think I watched quite a bit of those streams that they did, like introducing each of the electorates and all the people that were trying to go for each of the GRCs and SMCs. I think it was pretty interesting. So with that done, I think now going into this week, I think this week we have the elephant in the room, which is CloudNext. And CloudNext happened. And I hope, I think for those people in the audience, I hope you guys have been having a great time with, if you have signed up for CloudNext, I think you might have already received an email telling you, hey, please go see this blah, blah, blah sessions and whatnot. I watched a few of those. I think for the first week is slightly interesting. I think maybe not so much for the, the developers, programmers, or people in DevOps and all that. more on slightly on the business side. But I think there were still some things that they are trying to cater for us as well. And the activities on the side, there are things like study jams. Yeah. How have you been finding like those sessions?
I mean, the sessions are more like business oriented, but I mean that at the end of the day, that's what programmers' lives are, right? We are trying to create programs or develop automation to help solve, like a bunch of it is to help solve business problems. So it's kind of good to understand from another perspective of like, oh, okay, we have this set, like these industries are facing this set of challenges. And this is how Google kind of does it. So in the case where, let's say in your developer in your developer career, you happen to jump to such an industry, you kind of know that, oh, okay, maybe Google has some sort of product that kind of cover that form of the vertical. So I think they this time they cover like a hefty amount of vertical. I mean, it's really like there has been like that shift in focus, like instead of like, hey, check out all these new cool products from Google Cloud Platform. Now it's like, okay, if you were in the retail industry, these are the products that Google has developed, like with you in mind, with your profile in mind. So it's more like you can think of it as it's more enterprisey of sorts. Like they are more focused on the business guys. But then that doesn't mean that like smaller players, like let's say if you are doing like side projects, but that doesn't mean that we are all left out. There is something for everyone, but mostly now it's more for the business, for the bigger guys. But I hopefully in the next 8 weeks there will be some product releases for the smaller guys.
Yeah, I agree. I think the first session, or rather the first week itself, has been more centric around, like you mentioned, retail. I think there's healthcare as well. There's some finance case studies. There's one on gaming, which we're going to talk about later. I think that was interesting. I watched through the whole thing. How long was it? I think it was 15 minutes, something like that. But it was interesting. I think I was one of those that was actually a bit more techish as compared to the rest. And then I was really surprised when they did one on diversity. So just one dive video in Cloud Next, nothing to do with Cloud Next, nothing to do with, in fact, I think mainly they were just talking about diversity in Google in general, and what they do towards encouraging that. So I think for you guys, if you have not, if you have seen the Cloud Next, what do you call it, the session, the details that they have put out, or if you have not, do go ahead and we'll share the link with you guys later. You can watch all of them. There are videos, you can watch them at any time that you want. And there's also a list of activities you can do. We'll talk about that a bit later. So shall we get started with our human RSS for this week?
Yes.
Right, let's start. Okay, so human RSS, as have mentioned within the last few sessions that I've always keep saying, if you guys have any feedback or if you have any exciting stuff to show us or you want to share with the community, let us know. We will curate them and put them in. And yeah, let's get started. So first thing, shiny new stuff in GCP. So with Cloud Next, definitely there's a lot of things that we want to talk about. I think there's one big announcement where they talked about the new stuff announced in this first week. And I think what more to start by sharing about that announcement itself. So if you just to share this link over here, if you go to BitLYGDG7 next week one, you can actually see that there's it's actually a blog, an article on their blog telling about the different things that the new things they have announced. So you have things like BigQuery Omni, which we'll talk about later, confidential VMs, and they also have other things like assured workloads for government. I think this one is really interesting because if you guys have joining the the Cloud Extended last year in Singapore, you actually see that one part of the event, right, is catered to government services. Even though most of us are probably in the SME or enterprise or maybe big companies, but it's actually surprising to see that they put like one corner mainly just for public good or public services. And I think it's not just that. Like if you look at like other cloud providers like Microsoft, they had that 10 billion USD contract that they won in the US in 2019 last year. So it's a growing, I'll say it's a growing area, growing interest in the area as well for cloud providers to look into providing, sort of workspaces or areas or part of the cloud that governments can use, which will also include like the latest security protocols to ensure that they can use this cloud technologies and optimize it, for their own services, whatever that is created within individual governments. So yeah, that is an interesting thing to see. Although now it's just in private beta for the US. There's also the C2C. So C2C itself is it's termed as customer to community. So I think to sum it up, right, essentially it's a portal. You can actually, so if you go to this article, you can click that link. It should actually bring you to another article or immediately to a portal where you can sort of create your account and sort of interact with other users of GCP. So they want to create this as a portal for different users of GCP to be able to share solutions or whatnot, knowledge, know-hows with each other. And I think one of the other things they are also saying is that they want to make it a place where they can sort of share exclusive access into the roadmaps of GCP. But unfortunately now, again, this is it's for NA and EMEA, which is mainly Europe and Middle Eastern and Africa. So, but when I went over there, I think they didn't really restrict the page, as I was in Singapore. So, I mean, who knows? Maybe you can just try it out and see if it works for you. The last part, essentially, Google Cloud ISV, Software as a Service Center of Excellence. ISV itself, I believe, is referring to independent. Okay, so I have it written here: independent software vendors. So vendors who work in conjunction with cloud providers in creating services for other people. Or if you are just using their GCP for creating your SaaS products. So again, this is sort of the counterpart of C2C. So C2C was more like a portal for people to communicate. This one is more of like a program for you to communicate with Google in getting their assistant to help you create a center of excellence in your company. You can search up on the term center of excellence. It's actually quite an interesting read where they emphasize on having companies to build your own center of excellence as well as your center of excellence teams, where they are, they have different qualities. Like members in the center of excellence teams, they have the discipline to get things done. They have the know-hows to do things in different areas. They're empowered to do different things. So part of the sharings, I think, if you read through, what exactly is center of excellence, they actually tell you how you can sort of, or rather the qualities of building a team moving towards that. So if you go into this article, they actually will talk about the partner support. Like you can reach out to the partner customer manager, I think, of Google, and try and get to know from them how you can get this started. They have a few case studies in that article as well. So it's a kind of interesting read as well. Okay, so yeah, I would recommend, heavily recommend you can go to this link just to see, what are the big things they announced for this week. So let's talk about the other things that they announced over here. So let's start off with confidential computing VMs first. So maybe Harizan, can you talk to us about like what exactly this is?
I mean, to be honest, like I'm no security expert, but I can try to cover a few interesting aspects of this confidential computing. So I'm pretty sure that if you have went through all the security details on Google Cloud, they have this emphasis on like, okay, in order to ensure your workload is properly secure, you need to have ensure that whatever data that you have is encrypted at rest, and then in order to make sure that nobody like picks at your data while it's on transit, so you have all your HTTPS, SSL, and whatever. So that kind of covers your data in transit and data at rest. But then now with this whole confidential computing is to address another market. This market is like very, very particular about not having anyone to see that data. So I mean, because the other alternative is you have all this stuff all on your own on your own machines in your own premises, right? Because so that you can control everything. But then how do like providers like Google help with that? So AMD came with this feature with their Epic chips. I think over there on the slide, there was that mentioned. So these Epic chips apparently come with this thing called secure encryption virtualization. Details I'm not too sure, but to sum it up as a whole, what it essentially does is whatever workload that you're running, eventually you need to like store some of that data temporarily in memory. That data in memory is also encrypted. So the only time that it's decrypted is when it enters the chip in order for you to run some sort of compute on top of it. So it's like if your data, so you can imagine the whole process like, let's say if you need to read some data from your disk, you need to pull it out while it's in the encrypted form, it flows into the memory, it's still encrypted, and then it flows into your chip, and only there it is decrypted to have compute done on it. I will imagine like in the future, who knows, maybe compute can be done even on encrypted data, but yeah, there's probably a wild thing to happen. Naturally, with this confidential computing is naturally used alongside shielded VMs. So shielded VMs, if for those who are not too familiar with, is essentially it comes together with this feature of uh, like it ensures that your boot the booting of your VM is secure. Like there is some sort of key that they need to ensure that your OS is not tampered with. Like this is the OS that is okay to run for your application or some sort of like that. So uh, all of this has to be used in conjunction in order to have this confidential computing. It's not fully announced yet, so I think there are links here. And eventually will like put these links somewhere in the description. So there's that link there. That kind of points to the page where you can sign up to get confidential computing. I think right now it's not even beta yet. You need to ask for access to it. So yeah. So let's move on to and then these are the other two links as well. So you can go check out all these links. One of the links I think mentioned about some of the attack mitigations that this confidential computing VM hopes to kind of resolve. So I think one of them that might be interesting is this thing called kernel mapping or something, like from your host machine. If somehow Google's like host hypervisor is somehow compromised in some odd fashion, hopefully that never happens. But let's say if that one got compromised, it might become possible to actually read the stuff that's within the VM. I mean, I'm not too sure because like whatever that's in the article is a bit like thin on the details. So yeah, I mean it's kind of one area to look at. Because most of this content over here is all available in research papers. So yeah, it's going to be a long read if you want to go into the details. Yeah. So let's move on to the next one. Next interesting feature. Pretty sure like all those heavy users of BigQuery probably will be quite interested in this. So BigQuery is a nice product. BigQuery has always originally been on Google Cloud. Like, you don't see BigQuery on AWS or Azure or whatever. But with Google like having this emphasis on like, oh, you can use NTOS for everything, and NTOS is like deploying Kubernetes clusters on other cloud providers and all. So this BigQuery Omni kind of hitches a ride on top of that. So using using NTOS of sorts, you can deploy deploy some sort of clusters on other cloud providers, and then you can run the BigQuery engine on other cloud providers. So let's say if you have data in AWS or whatever, and then you want to use your familiar BigQuery interface to interact with your data, that is in AWS. So once you have all this whole thing deployed, this BigQuery Omni like comes to like solve that whole issue, like to have that BigQuery hook to AWS or Azure or whatever. So I think it's pretty interesting, but this feature like kind of comes along with NTOS. So I'm not too sure how like if you would just want to try it out, I'm not sure how it will go. Yeah.
It's quite interesting though. The Google is focusing. Okay, I think probably later on also we'll mention a bit about this, but it seems like in the past few webinars and then to now when we look at this, the focus has been a lot on cloud agnostic technologies. They're trying to build things that can work not just in GCP, but across like other infrastructures as well. So building this on top of NTOS, I think is really interesting.
Yes. But that's the thing. Like at the end of the day, I'm like performance-wise, not sure whether you'll take a hit. I mean, at the end of the day, it's a BigQuery engine deployed on other cloud provider. But then, depending on other cloud providers, the performance and everything might be better, slower, but most likely it'll be different. Like, you can expect some sort of like performance degradation because like maybe the engine is so maybe customized for Google. But yeah, at this moment, like it's who knows. It's a new product. People still need to try it out and all. And then let's go to the next one. Next one is also kind of interesting. So this one, so if you ever use like load balancers, like essentially most of the time load balancers, like you will load balance your applications on VMs that's in Google Cloud. So, but what if there's a case where one of your VMs is not exactly on Google? So this like now they have this capability where you can actually have Google Cloud Load Balancer like look at endpoints that is not within the Google Cloud ecosystem. So now you can potentially have it on premise or maybe on other cloud provider. So let's say if Google doesn't have a presence in a certain country, and then your workload can only operate within that country. Maybe this might be a possible solution so that you can have it go to the be load balanced properly, which can then you can have CDNs that read off that load balancer and all. So I guess it's kind of an extension to whatever we have. Yeah.
Okay, so let's move on to the next part. So tips and tricks, what do we have this week to share with you guys? So yeah, starting off, we have the G-Cloud command cheat sheet. So I don't think I've seen this before actually.
It's new. It was announced with one of the latest release of G-Cloud. So it's a 2-page PDF, I think. Yeah.
But this one does remind me of like I think maybe not G-Cloud, but I think I saw a similar one for Slack and GitHub. Yeah, and then they advise you to print it out and just paste it somewhere. This is pretty interesting.
Yeah, I guess the G-Cloud command is complex to the point that now you need like a cheat sheet just to be able to use it effectively. I mean, if you are familiar with the sound of commands, it's fine. But then, like, this tool can do almost anything on Google Cloud. And then looking at the Google Cloud ecosystem, it's like growing really, 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 really big. So I guess eventually one day this will happen. Well, I mean, and it happened. So yeah.
I mean, maybe this one is kind of like a small tip of my own, which is you can use something like this. And I think in addition, if you're using something, if you're using a Unix system, within a shell, right? Just I think one of the what do you call it? What do you call this? Combinations that I use the most, right? Is essentially Control R to search for all the previous commands that you did. And usually, I think it's either something like this. Usually, I either find a documentation for this or just do a Control R and find the most frequently used commands I've used before. I think all of those are usually very useful. But I think this one is really good. I haven't looked at this. So it's a 2-page cheat sheet on all the different commands. I think this is also quite useful for those who are going for the Associate Cloud Engineer certification, because I think one of the things that I realized after taking that certification exam is that they really ask a lot about these commands. Like they expect that you actually like remember some of these things. So actually, yeah, this is a pretty good material, I would say, in some sense, to also use for studying. Yeah. Okay, so let's move on to the next one. So yeah, I think a few weeks ago we talked about recommendations. So if you go to your GCP Cloud Console in the dashboard, I think previously there was only 2 tabs. So now there's actually a 3rd tab that allows you to see like recommendations. It's not like the recommendations API, but it's more of like the recommendations that they make towards you in terms of as the admin of a project in what you can do to perhaps I think in a few different verticals, like let's say restricting the IAM privileges for certain users if they have not been using them. So maybe you're over provisioning permissions. And the other one is, let's say if you're spending more resources, your VM is too big, but you're not utilizing it 100% of the time. So they'll tell you, maybe you can downsize, save some money. And the interesting thing is that the G-Cloud client, so it was in alpha and beta variants of G-Cloud, that client itself, for some time. And now it's actually pretty interesting that they also support it. Like I think now I just updated it last night, and I saw that it works. And so this one is how it will look like if you are looking from it from the web page or the console. And from your own terminal, you can also actually run the command itself to get the status. And it's actually quite interesting. I was actually looking at this and thinking maybe one day we can actually, because there's no alert system built on this yet. But let's say if you are in a big company where you have like over 100 Google Cloud projects, and you want to be able to have an overview of your recommendations, maybe I can save a bit of money by doing this to this VM in this one cluster, and then maybe in this other project I need to do this. I think having this G-Cloud client allows you to start looking to things like automating. Maybe you can just use something like the Cloud Scheduler, run this client maybe every day, once a day. In the morning you just run it. Get on, like in this case, this is in a JSON format. You can just pass it and put it out in a readable form, for yourself. So every single day you can have sort of this visibility or monitoring on your, like, it's not just monitoring on your on the let's say the success rate of your application or performance of your application. This is like going even deeper, telling you, how can you make it more secure in terms of IAM? How can you make it more optimized, cost optimized, in terms of the resources that you use? So I think it's quite interesting that you can actually use the G-Cloud client to get the recommendations right now. So you can check out you can search on the G-Cloud client's documentation for what they have on recommendations. Okay, let's move on to the next part. So for the next part, I think this week we're going to do it in a kind of like, we're going to mix it up and do it in a different format. Like instead of doing community content and learning content in like two different places, in fact, we're going to be featuring some content from Cloud Next and essentially sort of put them together. So we're just going to show you like what has been going on and what we saw within the sessions that has already been posted up, like the few videos that they have already put up. Okay, so I think this is without saying we have been repeating this probably too many times. Yep. So the elephant in the room probably is not longer elephant anymore. And if you're interested in Cloud Next on air, you have not signed up for it, you can go to this link over here, cloudwithgoogle.com/next/SF. It's a 9-week program. First week is on industry insights. Okay, so but the thing is this: even if you are not interested in the subject itself for the week, you can choose to not watch the videos. But there's also other activities that comes along with it. So we'll show you about that in a bit. Okay, so first week is industry insights. I've mentioned about it. The format is very simple. When you go to the within the Cloud Next on air page, you should be able to go inside the sessions and see what videos they have posted up. And as Harizah has introduced just now, they will go through the different verticals within, in this case, industry insights. Different verticals like retail. They talk about healthcare. How can different healthcare companies use GCP or the cloud in general towards augmenting their technologies. They also look at finance industries. They also look at the gaming industry. In fact, I'll talk about that in a bit. So it's very interesting. One thing I want to say is that actually, I would recommend that if you have the time, just go through maybe not so much into the opening keynote. I think it's a lot of overview. I'll talk about that in a bit as well. But the remaining videos, I'll say, just go ahead and look into it. If you find something that's interesting, like if you're interested in the diversity talk, you can look at that. Gaming, you can look at that as well. If you don't have enough time to look through all of them, then I would recommend watching a recap. But recap is really short. It's like I think it's 1.5 minutes. And if you look at the rest of the content, right, essentially the rest of the content is like there's like probably 8 to 10 different verticals, and those are like 15 minutes each. And the opening keynote is 45 minutes long or somewhere around there. So you can see that it's already like hours long of content. They just compress it down to 1 single minute, and it is really not a lot covered in that recap, to be honest. So I would actually recommend, just look through the videos that you're interested in. And so just to talk a bit more about like the community content so that they've shared with us. So in this case, the opening keynote. And to be honest with you, I watched through the entire 45 minutes, and I probably just watched through it again, like just to make sure I caught everything. But I think, to be honest, I have to admit I didn't really caught everything. I think it's really a lot to do with like a few subliminal messages that they are trying to deliver to us. And so you can see if you go to this link, you actually get to the video right away. But I think just to, like, I think if you watch early on, somewhere around like I think the 10th minute or 11th minute of the video, essentially if you take the screenshot, right, part of it, right, which mentions this, and this is essentially what they want to deliver during the entire keynote. That's how I feel about it, at least after watching it. And I think it's a lot to do with them trying to introduce to us, GCP, what they have been doing in terms of performance in general. How is it doing better now? Security, just now we talked about government, them trying to appeal more to the government. I think part of the outcome, trying to do that, they have tried to also, they've gone into making their services more secure, let's say as compared to before. But I think one very interesting point, if you see the last part, industry-specific digital transformation solutions, and I think some of the portions, I'm going to go to the next slide and show you very quickly, which is them emphasizing a lot on multi-cloud, which is something that maybe I kind of expected a little bit, but going into this, I think it was kind of like front, right, and center. Like, they're basically just putting this message out there. They really want to go with this direction, which is they are also acknowledging, along the lines that customers or clients may not want to have just one single use one single cloud provider. They might want to think about moving to another cloud provider some other time. They don't want to vendor lock themselves. These are all the things that companies are thinking about all the time. And I think it's a really good message they're sending across by trying to push things like BigQuery Omni, Untold, trying to make it such that you can use these systems that everybody is recommending, and you don't need to lock yourself to a single cloud provider. So it's really good to see them pushing this direction forward for all of us. Okay, so that's mainly for the opening keynote. And I think another thing that we want to share and feature is one of the different verticals, which is this one that the theme of this video is called Simplifying Complexity in Gaming. And essentially, they are actually trying to just describe to all of us, how you can use GCP to be able to build better games, and not just better games, scalable games, on a global level. For example, you can see over here, the 3 points they put here: build better games faster, be able to scale it better, optimize your experience, your players' user experience, through the different technologies and tools that they have, with things like AI as well. And I think it's a really interesting video that I watched through. They will cover different things like open source tools that they recommend, that they can use in conjunction with their different tools. And I think towards the end, you can also see that they did an interview with Activision Blizzard on talking about why Activision Blizzard chose Google Cloud, and what are the reasons they move towards doing that. So yeah, this is a really interesting video. I would recommend. I think compared to probably the other maybe 4 other videos that I watched, this one was something that probably was the most technical, I guess, in some sense. Then they actually talk about some of the tools, the open source tools, or some other tools that they are using, what they would recommend you to use towards achieving these different objectives over here. Yeah, so that's for the featured content. Okay. Anyway, yeah, so that rounds up the what we want to share with you in regards to CloudNext. If you have not signed up for it, I really recommend you to sign up for it. And another thing that we want to share with you, so this is something that they announced in regards to that comes along with CloudNext, which is the Google Cloud Learning Hub. So you can actually go into this site itself. They actually give you a recommendation, on what you can do per week towards learning, the different things that they discuss in that week itself. It's kind of like a very well fleshed out program. In fact, they give you all the materials required there. So just to give you a screenshot, so they'll tell you things like maybe you want to join the study jam. The study jam, they'll give you a code for that as well. And then you have a bunch of labs that you can do. Skill badge is something that I believe they introduced recently. I think it's not like the quest that we did before, but rather this is kind of not accreditation, but rather a sort of I guess a way to sort of self-certify and say that you're able to perform this few challenges lab or these different labs that cover that one single topic. And then of course there's also the other perspective. So Cloud Hero, I think that's another thing on Quick Labs. And then if you want to prepare for certification, I think this one, we're going to talk a bit about one of the links for certification later on as well. And I would very much recommend, like, during the period of Cloud Next, right, is actually a good time for you to get your certification, especially with all these different study jams going around. You know, you can learn a lot about the different things that come along with GCP, so you can actually use that knowledge within the exams as well. And you can also tune into other talks that they are going to be putting out in this period, and of course the sessions that we talked about earlier on. Okay, so again, the link over here is GDG7 Learn Hub. Okay, and I'm going to move on to the next one. Okay, so this is just a feature of what we showed in the last slide, the study jam. So every single Wednesday and Thursday around that period, they will be hosting a study jam, and this will go on for 9 weeks. So you can see over here, join us in 9 weeks of Cloud Next study, blah, 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 created selection for the learning resource. So this one is going to go on for this entire period. In fact, the study jam for this week has already been released. I believe there's a bunch of videos as well. I haven't really gone through the entire thing because it got released, I think, this morning, 11:30 this morning, if I'm not wrong. But you can look through it, this weekend if you have the time. Try out the Cloud Next Hero. It's also like a challenge lab of quick labs. And we can start all learning about GCP. Okay, and this one I think we'll probably talk about this to death already, and I'm going to talk about it again because for those who have not gotten your certification, this is a really good resource. You apply for this, you put in your details, they'll give you like a 1 month free voucher for quick labs, and another 2 vouchers for Coursera and I think Pluralsight, something like that. And they also give you a document where they recommend to you, what you should study for a couple of months. Maybe this month you can try out this quick labs, next month you'll try out Coursera, and then after that you'll finally get your certification examination. And I think that's a really good initiative. They're actually giving you like the free 1 month quick labs. They're actually going to try out, learn different things about GCP before actually committing to the exam itself. And not to mention, like, if you pass a certification exam, they'll give you swags as well. So it's not just certification. You probably can, I think you can get like things like water bottle bags or a hoodie, but I think you can choose one at a time, depending on what they have on offer at the moment. So do check out this link if you have not yet gotten the Associate Cloud Engineer certification. Okay, so after a very long blabber for me about Cloud Next, I hope you guys have enjoyed that part. I think up next we have we're going to be introducing our speaker. So we have our speaker today who's going to be telling us, as I'm going to read off the topic over here, the untold story of your code, mining software development history with deep learning. So we're going to learn in regards to his knowledge in terms of deep learning, and he's going to share with us today on this. So let's welcome Mikhail.
Hello, Mikhail. All right.
I think you're on mute right now.
Oh yeah, you're on mute. Okay.
All good?
Awesome.
All right.
Welcome
Welcome
to
your
over
slides.
the slides.
Yeah.
Okay, and the stage is now all you.
Hi, good evening, everyone. Hope you can hear me well. Thank you very much for introduction, guys, and thank you for giving me a chance to share some of the very interesting insights. I hope it will be interesting for you too. I wanted to tell you a bit about what we can really dig out of the code, and not just code, actually, the data that surrounds it also. And I will probably give you a bit of an introduction how this problem even started, how I started digging into that. Why would you even be interested in such things? How can you do basically the mining? What can you look into that? And what's available right now for us and how we can help, and what's in the future. So as an intro, I should just say that I'm not a software engineer, so you can start throwing your tomatoes in me. I'm a physicist. I was doing pretty much all my career modeling and simulations. So basically, I was trying to understand how the complex systems work and how can we predict them, how can we change them, how can we understand their behavior. And I was doing working on everything from tropical atmosphere to neurobiological systems, how our brain works, to financial markets, and basically to biological systems too. So a couple of years ago, I started looking for the next ambitious problem to solve. And with my co-founder, we were interviewing software engineering leaders, CTOs and VPs of engineering and developers who were leading the teams. And a very strange pattern started to appear. So after an interviews, I think we had probably about 130 interviews with CTOs all around the world. The very, very strange numbers about the scalability of the teams, the problems of the teams starting to pop up. The main question that we were asking in order to identify this problem was really on how much time do software engineers spend on coding, and basically what they should spend most of their time on and what they enjoy most of all. And the numbers were coming absolutely horrific. So basically less than a third at first we thought is being spent on coding, because a lot of time really being spent on comprehension, navigation through the code. If you put it in a more abstract numbers, then per weeks we nailed it down to basically 13.5 hours on technical depth and about 17 hours on maintenance. And as you can imagine, with maintenance, where you are just debugging or looking for code, a lot of the time is just looking for a place where the problem is rather than fixing it, which probably doesn't cost that much. And then filling all this from the community itself, we also did take a look at the industry reports and the research has been done. And ultimately, the numbers are like this, about 5 to 28 in the best teams, really. The average number is about 10% is being spent on coding among the software engineers. And I remember very clearly one of the CTOs saying that when they have a bug, sometimes it takes weeks for them to fix. And I was absolutely shocked. As an outsider, the physicist who is using just the products of the software engineering empire, I always thought that you guys are extremely efficient and very happy with coding and doing nothing else. But it appeared that really the problem is that the software engineering industry is just a victim of its own success and completely is overwhelmed by everything that have to be done. So the question that we were asking after that was what we really can do with it and how can we really help? How can we solve it? So a couple of years ago, I published a paper when I was building a mathematical model that helps historians to extract the data and insights from the books that they never read. And in order to do that, I used the graph theory and a couple of other mathematical tricks to help them to do that, really by just showing all the facts, the actors, and in their interactions in the form of the graphs. So and then I thought, well, if we can do it probably on textual data, then how can we do it on code? And very conveniently in code, you have Git, which stores all the versions and also the interactions. Now the question was that, okay, now we have data. We probably have mathematical tools. So all we have to do is just plug it together and then aim for success. But as always, there is a very interesting boundary that is always invisible between the research, the public perception, and engineering capabilities and everything else. So what I'll be doing for the rest of the talk probably is telling you really on now, given the problem and what we can really do and how we can approach it, how we can try to help engineers to spend less time on just trying to understand what's happening in the code, someone else's or their own, and more on coding and actually building new code and bringing more value. So what can we do right now? So if we look into this big field of mining of insights, mining code, and just the metadata run, we can see that there are a few main pillars out there. How people are trying to help engineers really to work more efficiently. One is code completion, and one of the recent tools, Aroma, is actually quite powerful. You can see that in this example, they give a completely different suggestions for code completion, just based on one letter that is being changed. Instead of app.getUser, which suggests set and logging, you are getting append when you have get users, which makes a lot of sense. It's a very interesting field. Probably have seen even that OpenAI recently started using the GPT model, which has been previously used to generate text and to generate code. It's super simple code, but still, this is something that is that's starting to pop up. The second one is code optimization. It's basically on how can we optimize the programs in order to increase their readability, to bring the conventions in there, etc. Third is automated code review, which is probably a holy grail for some parts of the community, because people do spend a lot of time on the code reviews, and a lot of time is being invested in that, and how we can help with code reviews and really make them, if not completely automated, then augmented by some of the insights digged using machine learning, is a big field, and there are a lot of interesting works being there. Bug detection and automated bug fixing is probably one of the most interesting, but at the same time one of the most difficult problems. Imagine that if you would have a problem and you had it probably 10 times before already, then it would be very obvious for a bug detected and automatically fixing tool to do it for you. But unfortunately, right now, we can do it on a very, very small subset of problems, and actually it doesn't, the advances there are moving very slowly. But there are some very interesting papers when the very deep learning models being trained on the bug history, and hence fixing the bugs just in one particular problem with a name-based detection. So basically, when you name something in a wrong way and it causes a bug, then these new problems are helping with that and fixing it actually quite efficiently, but just on this isolated part of the field. And finally, documentation generation. So this is something that I'm personally very interested in, because with documentation generation was probably the least favorite activity that all these engineers that I had a pleasure to talk to mentioned. So basically everyone hates writing documentation, and even more so updating it. So if we are talking about the bug detection or code reviews, then people kind of split half-half, whether they like or don't really like doing that. But documentation is a really notorious activity. But at the same time, it would be possible to address this problem with all the advances in NLP that we're having, and in general with a lot of mathematical models that's been available during the last probably couple of years. So before I start going a bit deeper into documentation, I will just share with you the problem that I had. And I was not very familiar with JavaScript. So when I started learning it in order to help engineers better, I understood that there are some absolutely fantastic things that for me, a lover of C, C++, and Python, were probably unimaginable. So unfortunately, I can't see you, but I just suggest you do it with me. So if you run this string, what do you think will be true or false? So I think pretty much everyone will be correct, because you're, again, much more experienced than I am. But if you run this string, would you get true or false? Actually, you can send the comments, because I think we have a comment section. So this one will be true, actually. And this fantastic example of unpredictability of some of the languages is just anecdotal, because it's simple. Once you know it, it's not a problem. But the fact that there are many such caveats in languages, and especially once we go into more complex structures, really just reminds us that documentation is important, and it's important to help yourself and to help others with understanding of the code. So what can we really do with code in order to extract the intelligence that we can then use for either of the 5 pillars that I mentioned before, from completion to documentation? Well, first of all, in order to understand of what we can do is, I will ask you a couple of questions. So the first question is that now if we analyze Git, then we'll have the text and code. So what is really text? Text can be represented in many different ways. It can be represented as a sequence of bytes, characters, tokens, or a tree. And if I ask you what is really code, then the code is actually the same. It can be also represented as a sequence of bytes, characters, tokens, or as a tree, which sounds fantastic, because well, they can be represented in the same way, which means that probably to learn from code and text as a pair, semantic pair, especially since we have them together already in Git, would be just pretty straightforward. Unfortunately, code is very different from text, and although a lot of things are being shared, there are some very, very big differences. The degrees of freedom that we have in code and text are completely different. You know that the code follows a very strict logic, and which cannot be violated. Otherwise, you will never run the code. While in text, you can just basically have new phrases. You can invent new words, etc. And it will only help language. Actually, it will only help the understandability. So on all these different levels, semantics and syntax and regularity, there are huge differences between code and text. And when we will be analyzing them now with you, we have to remember that. And that although they're very similar, we have to always address them separately and really fit the models for them, keeping in mind their own strengths and weaknesses. So now that we know that code and text really can be represented in many different ways, this is probably the most critical question: is how do we really, what way of representation do we want to choose to solve our problem, which is, in our case, will be probably generation of some kind of documentation, but it could be anything else. Again, it could be a code completion, because in order to complete the code, you still have to extract the intelligence from the code and then use this intelligence in order to suggest code, the code completion algorithm. And this is probably one of the most important slides, if not the most important, which I would like you to take away. And it basically shows you that there is no silver bullet in this problem. Is that you can't just choose one of these representations and get the perfect solution. Because if you try to work with the code as just a token stream, which is a fantastic idea because it will help you to analyze code in any language, the problem would be that actually your models will be so big that it will be absolutely impossible to train them to get any meaningful results. But as long as you will try to introduce more and more intelligence into your model and treat code not just as a token stream and not as just stream of characters, subtokens, or even tokens, but you will try to put more regularities, more patterns, more connections, then the less and less applicability will be following this process. So you basically have these two extremes. One extreme is that you have a language agnostic but humongous model, which is almost impossible to train and then to keep it updated. On another extreme, you have extremely well working model that is super finely, precisely tuned to your particular problem, and for anything that is slightly different from that, you will have to use something else. So to find a balance on this graph, really, that depends on your problem, is, I think, the most interesting research problem that everyone who is working on machine learning on code or trying to build any AI models to extract intelligence from code is dealing with. And there is, again, no silver bullet to it. You have to find a balance. You probably have to find a combination. And in our work, we really combine a lot of different representations that are all probably in the middle of this graph. Let me look a bit into that. So, as we said before, the code can be represented in many different ways. And one of them, as you remember, it was a tree. So if we have here in this example just the Java code on the left side, then you can imagine that the characters, what the character string will be, what the byte string will be, and even what the token string will be. So here the tokens will be public, class, C, etc. And now, what is the tree really? Because the tree is a very interesting abstraction, very powerful, that it encapsulates a lot of semantics. So the tree here in the center is basically just how all these tokens within this piece of code are related to each other, and then how they interact. So you can see that basically you have public class C, which is here, and it's being here named as a name as a class with a particular name, particular modifier. It has members, and then the method within this class has also its name, etc., etc. So with this tree structure, you can do a lot of things, actually. You can look at every particular token, just like here, and analyze it separately. You can analyze it with a certain neighborhood, say with a token on the left or a token on the right. And then most interestingly, you can also analyze this tree by just walking through it from one terminal node to another one, say from M in the name of the method body to the M as the name of the call. And let me tell you a bit more about it in a minute, because not just a representation of the code elements is important, but also the context. As you can imagine, if we will be just analyzing and learning our model on the tokens or on the subtokens or even on the ASTs themselves, then, for example, for token public, I mean, it's probably not very helpful to train a model on it without understanding whether it's a public as a identifier name, or whether it's a method name, or whether it's just a public class actually being called here. So the context, the neighborhood, is extremely important in order to catch the semantics of what is actually going on in code. And you can look again at the code context in many different ways. And that's, again, the second level of complexity, and it brings a lot of interesting problems with itself. So you can look at the context in the neighborhood of subtokens, tokens, AST nodes, and AST paths again. So just as with in the very beginning, we again have this Russian doll structure of context and of mathematical representations of them. So now imagine that you now trying to understand what a particular node really mean here. And what you can do, you can just look at it in a way of analyzing it character by character, just as a token itself. Again, neighborhood of tokens, AST tree altogether, or the AST paths. And the paths are probably one of the most interesting ones, although they don't always give you the best solutions, but they encapsulate a very interesting semantic information. So what is really a path is, imagine that here you have, so here we have three different snippets, and all snippets, they have a terminal node. So these are basically the nodes in a tree that do not have, that are final in a logical chain. And what you do is you connect two terminal nodes into a loop, and this loop is a path. And very interestingly here, for example, in example A, you can see that the terminal nodes are elements and true, and the path basically goes through the tree, connecting them, and it encapsulates the whole for loop here. There are other paths in this abstract syntax tree. They are number 2, which connects false and target, 3 boolean and f, 4 object and target. They all actually encapsulate semantics and how this tree can be interpreted, but it's not as powerful as the first path, which, although is the same concept and the same mathematical representation, it has much deeper context and helps us actually to understand much better what's going on in the code. The same in the snippet B and the same in the snippet C. So you can see that in the snippet C, for example, there are some ST paths that are connecting, again, the elements within the for loop, and basically the whole for loop is being then within one path, and we can understand everything that is going on there. But at the same time, you can just have an example C, just a short loop when the identifier has addition at every step of the for loop, and then it's being returned. So when we analyze different neighborhoods and different representations, basically the context of these representations, then we can encapsulate again the different levels of semantics of the code. Okay, so let me pause here and ask whether you have any questions. If you do, please leave them in the comments, and I think I will be happy to answer them. Otherwise, we can keep them for the later part. So if you missed, if you lost me somewhere, then probably the most important thing again is just to think that is just to remember this slide, is that the code and the text, which actually represent the metadata that surrounds code, can be represented in many different ways. The context in which code and text exists also can be represented in many ways, and these ways are basically just the different levels of granularity. So imagine that how you are learning language, when you can learn it just by words, but sometimes you are learning phrases, the complete phrases, and it actually helps you to reduce the memory when you're using it. So it's very much the same with the models. You can analyze the code and extract intelligence on the level of tokens, but also the trees, parts of these trees. You can even build a bigger objects and do a semantic or dependency analysis of big structures in code. So now, how can we use these different representations for the problems that we described before? So basically, when we are treating code as a sequence of bytes, then not much can be done, obviously. But once we look at the sequence of characters, then we can already have a character encoder, and it is helping us. It can help us with the autocompletion. So we can train the model just on the code representation when every element is just a character. And once we have this character encoder, then basically the model can suggest us the next character. It's very simple, but it's already something. If we analyze and represent code as a sequence of tokens, then we can have then we can train the models which are very similar to Word2Vec. If you did have a chance to play with NLP, that it's one of the most famous models that is basically telling you on how the different words are related to each other in a language. So, for example, they will tell you that mother is as relevant to father as a queen to king. So you can start training the similar models on code already, which will be helping you to understand that if you have a particular token, which is probably identifier or a method or method name, that you can expect a next token there. So this is very similar to the problem of the code completion that we have seen in the very beginning. And it's very understandable that one change in one character will give you a completely different outputs of the model, because you treat it again as a set of tokens. And these tokens, as we mentioned before, was also have a particular neighborhood, the context that you take into account. And finally, you also can take a look at the code in a way of an abstract syntax tree. And then this abstract syntax tree will help you with the code summarization. So when you have a different trees within your big project, then you understand which blocks are really, which blocks do you have, how do they relate to each other, and how you can simplify or reshuffle the whole structure of code in order to optimize it, for example, or just actually to generate documentation or to help to understand what a particular piece of code is doing. So in order to probably give you a bit more of how this all theoretical in base can be used in order to solve the problems that we started with, I'll give you an example of one of the features actually that we worked on is a semantic search on code. And basically a semantic search, just as on text, helps you to find the code where you don't know exactly the names of the elements, but you know what they should be doing, what semantics or what meaning they should represent, and what the relationships that they also should have. And for semantic search, just as on text, basically the central idea is to represent the code and the text in the one space in which you can then train the model in order to understand how they are related, so that you can search on code using natural language. Okay, so basically what it means is that imagine that you want to have you want to find a user logging in your code, but you're not sure whether the exact words of user and logging being used in code. So the semantic search will allow you to find user logging in code, even if they're being used called USR PSW, for example. So again, we have to build pairs there between the code on which we will be searching and the language which we will be using in order to search something. Then we will build the code encoder, the language encoder, combine them together, and then basically training our model. So this probably look a bit technical. I'll show you right now how it works. The idea behind it is that if we put all the elements that we have in code in one big field, in semantic field, then those elements in the code that are very close to each other by meaning, they will lie next to each other. So this is just a plot as an example from one of the repos that we processed. And here you can see that there are very different ways on how the software engineers were calling basically how they were initiating the creation of the article. And all of these different ways of calling it has been analyzed and put together, so that whenever a user is really searching for creating article, making article, or just initiating article or initiating a post, all these pieces of code could be found. So in our platform, we, as I said, we have semantic search, which I'll show you right now, but we also did different parts of different elements that also uses the insights from the code analysis, such as code summarization, function name prediction, and finally question generation, topic modeling, etc. So let me jump into an example that probably will show you on how the semantic search really works. So this is the platform that we've built, and here you see that's just some repos from the GitHub that's been processed, and let's go into one of them and see of what we've got for it. So everything that you see here is automatically generated by the models that analyze the code in a method that I told you just before, and then generating insights in the form of questions, answers, semantic labels that are basically describing what's happening in the code. But let's take a look on how the semantic search will work. So basically, we can search for anything, and this is the so this repo is a self-hosted chat app. So for chats, what can we do for chats? So for example, we have an ID of a chat room and we want to search for it. So how can we find a chat room by ID? And I have here the GitHub repo, and let's try to find here the chat room by ID. So most probably we will not be able to find anything. So there is one element from the code. I think if I'll put find, then probably will not even get this. Yeah. So unfortunately, you have to, as you know, always know what exactly how it's being named in code. But if you use a semantic search, then we should be able to get something more interesting. Probably here, but here the find will be very important because we want to find it. Okay, so yeah, you see immediately that the results that started to come up, they are actually pretty much about what we wanted to find. Although here all the words are being used, actually find room, a chat room is not just being used. The GitHub is not able to find it, but we can do that. Another interesting thing is that we're also generating semantic labels that are basically telling you of what a particular they work as a summary. They're telling you what a particular piece of code is doing, and you can navigate and search through it. So, for example, if you're interested in all pieces of code that are related to HTTP API, or even more concretely to HTTP requests and HTTP API, then you will be able to see them together immediately. As you can see, there is a way on how you can query users in the rooms, etc. So basically, as I said, the most interesting thing here is that all this data that we generate, all these insights, they're completely automatically generated without any inputs from us. And as a physicist, I most probably would not be even able to do that, especially for JavaScript that I like now with all my heart. But I think it's pretty interesting that by trying to create this shared vector space in which we combine both code and natural language, indeed these matches can happen. Okay, so so the thing is that probably then everything will be solved, but the problem is that there are still a lot of problems, and the problems, as you know, probably if you ever were interested in machine learning problems, is that the data is not perfect, really. And the data is not perfect because it's being produced by humans, and humans always introduce a very interesting mistakes that they themselves and definitely the computational systems are struggling with. But nevertheless, the advances that has been done in both mathematical theory and in computational capabilities and all the engineering tools that the guys were talking before, helping a big deal, because without the data, without the computational resources and engineering resources, it will definitely be not possible to even touch these problems. So one of the results that I wanted to show you in the end is quite anecdotal, and it is totally related to what I said before about the data that's being introduced, and it's sometimes very difficult to analyze. So here you can see that all the identifiers that are being plotted for one pretty big repository. You all are familiar with that, and those dots that are closer to each other, they are calling each other more often, and they're also being changed together. And the most interesting ones here are those the outliers, basically those dots that are on the edges, because it means that either they haven't been changed recently, or they don't have much of a relationship to most of the code, which is not such a big deal. But the fact that they haven't been changed or updated recently sometimes could cause the problem, and that's why we analyze them separately. And this is the most interesting dot that I did find here, because it's being called that this is a secret DOM and do not use or you will be fired. And such names actually happen to exist, and not in this isolated case, but all over the different repos that we process and analyze. And this definitely creates a challenge and makes the whole problem a very, very interesting one. And by the way, this is the React by Facebook, so you would be surprised to learn that this is probably that even they have such inefficiencies in their code. So, but given all these problems, I think it's clearly with advances that we recently have, there is a change in how we really write the code and how we analyze the code, given that we can now extract more intelligence from what has been already written, and how we can communicate to each other and to ourselves from the past. And both Google and Facebook have developed code search. You know that Google code search is now used 5, maybe 10 times daily by almost every Google technical employee for the last years, and 98% of the developers say that it's critical to their job. Really, they I think invested about $100 million already, with dozens of full-time engineers building this. So the semantic search and their more advanced versions are definitely definitely of a very big interest, and I think should help us all. But it's also, what is very interesting, I think, is that developers who use the internal knowledge sources has been proved to be almost 2 times more likely to be productive by recent research from 2019. And hence, if we will be able really to resurface the the intelligence from the code that we have already developed within the team, or even from the open source community in GitHub, then we definitely can all be more productive and write more code, what I guess everyone is trying to do and aspiring for. Thank you, everyone, and I'd be happy to take questions if you have any.
Hello there. Okay, so we got one question essentially from Wei Yan. So Wei Yan, you want to read your question?
Sure, yeah, I was interested to see if this can be used to replace documentation. Like, I think the idea is code documentation allows us to be able to hand over context, or rather the context is not siloed up with a single team member. So you write documentation so that, even if, let's say, a person leaves the company, another person can read the documentation and understand the code right away. But if you have when you can search context from a piece of literature, a piece of code, it seems like, would it be able to replace documentation? Like, I thought it was a very interesting thing to be able to search for context in the first place.
That's what we're aiming for, yeah. I think that human-produced documentation is just extremely inefficient because we are bad in that, and we should not be doing that. I think we should be just writing code and write good code as good as possible. And if we will be doing that, then all documentation can be automatically generated. You can just set up your own format, actually. I mean, this is another thing which I mentioned just briefly in the beginning. But if you set a code convention or documentation convention, then it's not difficult to train a model that will be converting the intelligence from the code into exactly the convention of documentation that you want to have. When you want to have in a few paragraphs, or you want to have bullet points, we can do it for you.
Okay, maybe I'll read my next question, which just synced up as well. So I think one of the things I like about Google Cloud Platform is be able to create your CI/CD pipelines using Cloud Build. And I think one of the things is, so I think looking at like what you shared today, I was just thinking, okay, so let's say documentation, is a good replacement. How about unit tests? Like, if we can in some way communicate the intention. So let's say not from reading the code to get an intention, but rather passing the context in another way, and to let the AI take over and say, check to see if this code represents that context properly with all the corner cases. Do you think that would be something that's achievable?
I think I know that people are working on that too. I think there is definitely a lot of work that can be done and is like being now researched. How can we help with the unit tests? Because I guess you know probably better than I do on how much time is being spent on that. And actually probably more time is being wasted on when the unit test has not been built, and then backwards guess that, okay, we should probably have been having the unit test that would have found this problem beforehand. But it's a bit tricky whenever you deal with a new code that has the basically unique unit tests. So it's not such a big problem to have a model that will be suggesting you the unit tests on the code that is somewhat similar to existing ones. It doesn't even have to be it doesn't have to exist in your company. It can, for example, exist in open source, and then the model can train from that too. But if it's a completely innovative piece of code, then it will be very difficult to create a unit test for that. So we don't have a creative AI yet. So that's just to make sure.
Yeah, I guess if you can reach to that extent, probably that AI can even write the code, not even caring about unit tests. Yeah.
I think humans are extremely a beautiful creative machines. I mean, we're very bad in repeating and doing algorithmic work. That's actually why we're bad in documentation, because it's not interesting, it's boring for us. That's why we're bad at that. But we all like to create new things, and it's I think we're very good at that. And that's why I would not be worried if I would be a software engineer that my work will be done by robots in 10 years. The most boring parts, yes, probably, but the most interesting creative parts will definitely be still done by humans.
I got a random question from my end. So just now during the whole presentation, you were mentioning about how it might be possible to suggest ways to make the code more readable, right? I mean, that's kind of one of the things that I caught from the presentation. So I just wondering, like, how does one, like, let's say in your data, right? How do you define like which code is more readable than the other? Like, what kind of parameters? What kind of things are you looking out for to determine that this code is more readable than another?
Yeah, this is a good question, but it cannot be done automatically by machine completely. In a sense, it can semi-automatically decide upon that if you give a machine a model, if you train a model basically on a set of well-rated and well-readable pieces of code and the badly written, poorly readable, then it will definitely catch patterns, and based on that, we'll be able to predict whether a new piece of code is more or less readable. But actually, when I was saying it before about that, I was mentioning the research in which they had a very well-defined set of parameters, and they used this set of parameters in order to then train a model that was pushing the code into a more readable form, into optimized form. So imagine that it's basically bringing your code automatically into convention of your team. So if you want to have a certain patterns in how the code is structured, that can help you to follow these patterns while you are writing it. It could be names, it could be, I don't know, spaces, how the different blocks of the code are orchestrated together.
Okay, because I mean, like, as of now, the only things I've seen in order to like force programmers to write better readable code is via heuristics, and that is seriously one
Pretty
thing.
horrible, I think.
Yeah, it's horrible as hell. Like, imagine you submit the thing, you thought everything is working, unit tests are all passing, and then it stops at the one segment that says your code is considered not readable by a machine. You pass it to a human, like, yeah, I can read it, but why did the machine say it's not readable?
Yeah, no, I understand you. I agree with you completely, and that's why I think that it's more useful, at least right now at this stage, is just to resurface the intelligence that is already there for the humans, rather than to force us all to work as machines, because we are not machines actually in the first place.
Yeah. Then I have another question as well. So I mean, right now, you did mention about the tool that you have was looking at code in GitHub and all, right?
Mm-hmm.
So code on GitHub, I'm pretty sure right now there's a majority of code that's actually outdated, has never been updated for the past 2-3 years. So is that something that you need to be kind of aware of, like when you're training your model, to make sure that your code is based on selected versions of programming language? Because, like, okay, let's say, give you an example, right? I work with Golang, and Golang between the various versions have different styles and different patterns being introduced per version. So does that mean that every version of Golang will generate a different model of this semantic search or something like that?
This is a very good question, actually. So the quick answer to that is that we have a sophisticated set of parameters that we are looking at, and we're trying not to train the model on the poorly written code, on the very outdated written code, etc. But actually, if you remember the graph that I said probably is most important one, with the with a graph, then you should remember that there are different representations of code that are helping us to capture the different semantics of it. So you actually can, and when you analyze the Golang over the different versions, that certain things are changing, but other things are staying the same. That's why it's so important to analyze code at different levels of granularity, really, because there are different patterns, and there is no single model that will help you to capture the different levels of semantics. So that's why we build a big kind of a big number of different models that are looking at code from very different perspectives, and then giving you the intelligence already in a summarized manner. So to answer your questions, some models will be looking only at a particular version. Some models will be looking at the code in a very limited way, but across all the versions. And then we will merge the results.
Okay, and I mean, just another question, just out of curiosity. So previously, I used to work in the search team in my current company, and I then search usually goes through multiple processes. So one of the process involved is this process called indexing. So does this semantic search for code, does it go through that same process as well? There's an indexing phase that takes a long time to complete?
We're definitely indexing the search itself has not been invented by us. I mean, you know that there is Elasticsearch, which I think is a fantastic thing. BigQuery is actually another fantastic thing. I mean, they all use indexes, and we do indexing. We try to do it in a dynamic way, which means that so that we don't have to reindex everything after another analyzed repo. But yeah, we do indexing on the last stages where you already implement the search itself, because I guess without index, it's pretty difficult to build a search engine.
All right. So far, it looks like there's no other questions coming from the audience. Wei-Yan, do you have any other questions?
I don't have any other questions as well.
Yeah. So for anyone in the audience, if there's any questions that you kind of wonder and all, you can just put it into the comment section. Then if you ever catch it and all, we will forward the questions to Dr. Mikhail. And then maybe in the future, if those questions were raised are valid and good, we also will try to cover them and put them into an article of sorts. So yep.
Cool. I'll be happy to answer them, obviously.
Yeah, that's good. All right. So with that, that comes to the end of the session for this one. So I mean, there are other announcements that we need to cover. So for now, Dr. Mikhail, thanks for your presentation.
Thank you, guys.
Yeah, hopefully you'll come again and present on more advanced topics. Some of these parts kind of go over my head. I probably need to rewatch bits and pieces of the video over again. Cool. All right. Thanks.
Thank you, guys. Thank you for inviting.
See ya. All right. So let's finish up.
Okay, so we're back again. Again, I think this is probably the 6th or 7th time, maybe 10 times that we're mentioning about Cloud Next on Air. And yeah, it's an awesome event. 9 weeks of things for you to try out, videos for you to watch, study jams, which consists of curated topics, the Cloud Next Hero for you to try out to get the Quest badge yourself. And yeah, very much recommend for you guys to check out the Cloud Next on Air and their learning hub. Engage yourself. Let's say during the weekends, if you have free time to look into this, you can definitely go check this out. And let's look at next. All right, so we are going to have our next webinar. So that's going to be 2 weeks from now, the same timing on Thursday from 7:30 to 9 p.m. So we will confirm the topic later on. So check out our meetup page. We will post our contents, more details on this later on. And we're always looking for speakers. If you have topics that you're interested to speak about, there are things that you want to share with the community, things that you have worked on in the company, or things you have worked on the freelance, or even by yourself, you want to share it with us and the community. And this is not just limited to cloud topics. Our sister group for GDG Singapore, they also look into speakers for topics under Chrome, Android, web technologies, TensorFlow, Kotlin, and definitely, for GCP, if you're also looking for people in TensorFlow, Firebase, GCP, definitely, so on and so forth. So if you have any interesting topics in this spectrum, do sign up at this link, write into us. We'll get in touch with you once you've done so. And last but not least, we have a bunch of social media platforms, outlets, whatnot. So most important part, meetup page. All our events goes there. If you want to subscribe to our events, like you subscribe for our group, you'll see all the events that we post up, new events that are coming. And definitely you can just keep yourself in touch, with our latest events there. Facebook, definitely. Facebook, we do answer questions. We post certain topics there once in a while. Not once in a while, actually, quite frequently. I think Harizan posts a lot as well. And do join us at the Facebook group and also our Slack group. We previously use this in our for study jams, and you can continue to use this to discuss with other community members, in regards to problems you have using GCP, so on and so forth. So make sure you follow all our different social good stuff here and social media stuff, I mean. And if you like this live stream, if you're on YouTube, give us a like, share, subscribe, all that good stuff. If you're on Facebook, like us, share us as well. And definitely let us know, in the comments if you have any, comments on things that we can improve or things that you want to share, maybe the next human RSS. Let us know all about this. And with that, we have come to the end of webinar 7. So hopefully, we'll see you guys, in the next few weeks for Cloud Next. It's gonna be week 3 of Cloud Next when we come back, and we're gonna have a lot more to talk about with you guys. So see you guys in webinar number 8 for 30th of July. Bye bye.